So welcome everyone. This is a meeting with the Neuropil cybersecurity mesh work and group. We started this also in the context of the Disposable Identities group that's on Telegram, and which you can also find if you put it in a search engine, Disposable Identities, you find a website and you find a link to the Telegram. And we started that group basically because we are now fully in a hybrid world. So it's no longer analog plus or analog plus digital. It's a whole kind of new weaving of networks in which individuals need to rethink their notion of identity, and basically should be as much as possible in be able to have this own identity and to expose themselves to different persons and different institutions in different ways. And in that context, or maybe not in that context, but we're here later, but sort of in this kind of broad context, we have a talk this evening. So please, if you would introduce yourself and then please go ahead.
Yes, so thank you, Rob. Also, I think we can make this talk maybe a bit interactive. So whenever you or anybody else has a question, either directly raise it or interrupt me. Or if you think that what I'm saying is boring, then also interrupt me and I can maybe speed up a bit, we can see. I'm Stefan Schwichtenberg. I'm here for Pilar, that's a German company. And we started a development that we now call Neuropil Cybersecurity Mesh. And we are in contact with a disposable identity group because we also use disposable identities or a kind of disposable identities in our solutions. And that is what I'm also going to present later. How do all the digital identities play together to basically then form this cybersecurity mesh? So my talk will be a bit starting from the past. So what is the current state of cybersecurity? And the talk is called Reality versus Cybersecurity. And you can see the gate on the right side, which you mentioned it already, Rob, is quite useless to use it. It's quite useless to close it then as well. But actually, for me, it's always a sign that we try to implement cybersecurity measures like this gate. But sometimes we forget that somebody can just walk left around it or right around it. So we implement sometimes cybersecurity measures that are completely useless. So I don't know why this gate is there. Nobody knows, but it's a nice picture. All right. So my name, I already introduced myself a bit. I founded Pilar GmbH in Germany 2014. And I'm working in the enterprise security architecture field. And we started the open source development of our cybersecurity mesh already in 2016. So it's not something that came out of thin air, but it's actually based on our experiences on working in the field of enterprise security and in enterprise integration. And then later we discovered many other, I would say, contact points or other things that match with our development. And we also received a few fundings from the Next Generation Internet program. I will also mention that later. And now we are with our cybersecurity mesh somewhere where we never wanted to be, or no, not where we that's good where we are, but where we never intended to be. So that's the right word. Okay, so let's have a bit a look at the past. And I will always call it limitations of cybersecurity. So if you look at the right side at the picture, you have like a robot arm, and you have the different kind of partners that the robot arm has to communicate with. And that's a typical picture how you would start the integration of the robot arm. So you need to integrate software updates. You need to integrate if a service partner is coming, if you would like to receive data from the value chain. So goods that are delivered or the products that are then shipped to your customers and so on. And that is how you would typically start to implement then. And that is actually a rather static point of view on the whole architecture. So you're looking at these bilateral IP connections that you need to make. And then in the end, you think that you are ready to go and that you have integrated the robot arm successfully into your company. And if you then look at the real world, that is rather looking like this. It's rather confusing. So the maintenance engineer sometimes would like to access the robot from remote. Sometimes he would like to get into the company to do its maintenance work. The products constantly change. Maybe the software updates that you need to get for the robot. Now you need to get them from a different company because the company was sold. And that is not, in principle, everything is doable. But the point is we have started with a rather static design. And we are then, with each change, basically, we are entering or we are adding security exceptions because we are humans. We are humans and we forget things. We forget to remove firewall clearances. We forget to remove accounts, to disable accounts. And that leaves, in the end, vulnerabilities in your IT landscape, although maybe on the beginning, on the blueprint, no vulnerability was there. Maybe you can't do any more the software updates. And that is limiting cybersecurity. And on top of that, you have to see that we have an enormous amount of protocol and complexity in our internet today, and protocol fragmentation. So there are different kind of protocols with different kind of security levels that have to interplay. And in the end, if you look at a complete company, nobody can actually tell you whether your company is secure or not, because it's such a complexity to manage. And you don't actually know necessarily whether you have managed all of them. So in cybersecurity, you are basically taking always a risk-based approach, and you try to reduce your risk, and you try to reduce your security holes. And in the end, you hope that you are not being attacked because somebody else is there who can be attacked easier. And we can discuss whether this is a good approach or not. For my opinion, we can do this for old IT infrastructure, then we can reduce risk. But for anything that is new, we shouldn't take this approach. And
Just
the main
briefly, I just want to interrupt that. Vishal asked me if I could activate an AI companion, and I did.
Yeah.
So I'm not
Okay.
sure what the AI companion is going to do. So, but I think it's going to take some notes or not, but just to inform you that we have a sixth participant, which is
Okay. That's fine. So I have to click OK, right? Yeah. So the point is we are the internet as it is today. That is because it was based on a completely different assumptions. So the internet, as it was started, was by scientists, and everybody was friendly. So there was no evil person in the room in the internet. And there are a lot of these assumptions. So we have started to develop the internet over time, and now we have all this complexity. And we discover that we are not in this friendly world anymore. So not at all. So the world has changed a lot. And there are also a lot of assumptions like I'm immune to phishing, or there are no evil persons. I already mentioned it. It's all about user awareness. So it's always the user who is clicking on the wrong link. No, it's also about that our software is not in the state to actually cope with a new reality. And that is also why the talk is called Reality versus Cybersecurity, because we are coming from the past, but somehow our tooling is not fit for the future. So we are kind of still stuck with the old tooling, but we have to move on. So the idea would be in the next part, what kind of features do you want to have if you talk about cybersecurity? And one of the influences that is currently mostly prominent, that is zero trust architectures. That means you would like to not only build something, but also verify that it is working. So the slogan of zero trust architectures is never trust, always verify. And that means always build it also in a way that you can verify that your cybersecurity measures are working and that they are actually in place. So it doesn't help if you build somewhere a firewall, but it's never cannot be attacked by, and it's just useless. Zero trust also says that there is no trust perimeter. So we are used to have the notion of external and internal network, for example. But once you understand that many attacks on your company are based or are actually happening because there is an internal actor, it doesn't mean that he has to be malicious. It's just by clicking on the phishing link, you are getting malware onto one of your computers, and from there on, the attacker can then actually attack all your company. So we have to be much more, we have to reduce the granularity. We have to basically reduce the perimeter and introduce much smaller zones of trust. And zero trust basically is about everything is a gateway. So instead of just having doing the boundary around our company, you could say that every computer should be a gateway or should be guarded by access control. And then we can authenticate and authorize everywhere in our architecture. And that will make it much more difficult for attackers to basically get any information. Also, what we have seen is that the information in a company or the information flows is the part that need protection. And that we are trying to get the different kind of information together, and there it needs to be our intention. We don't need to look, so when we protect all the different assets, then we also need to take a look at all the different information flows in a company. And actually, it's the information flows that give you a benefit if you can combine them easily for new data flows. Okay, second inspiration that we can get, that is the sector of named data networks. So that is a new approach. It's completely unrelated to our work, actually. But named data works argue that the IP address or the DNS name is the wrong destination for any kind of data channels. Instead, they say we should really use the name of data objects, and we should use these as addresses. So IP addresses are still there in their stack, but they are just a means to resolve the names. And that actually directly brings you to data provenance. So if you have an address that is based on a name, then of course you can attach it to an identity, and then you always know where the data is coming from. And the approach from named data networks is especially well suited for distribution networks like CDN networks, and it removes a lot of middleware technologies. So we have a lot of middleware in place in our internet that is then not needed anymore. So this is a new development and a completely new approach how we could evolve the internet. Then we have data spaces. So we would like to share data in a completely different way than before. So right now we are looking at systems and we try to integrate systems, but actually we would like to integrate data, and we would like to produce or consume data all the time, and it can change. We have done projects that in 1 year we shuffled the data from one company to the other, and in the next year, due to legal reasons, we had to do the reverse for the exactly same data. So it's the data flows are changing all the time, and we would like to respect data owners actually. And there can be more than one data owner. We have seen that in the pandemic, for example. If you have the information about the virus infections, then you are, of course, a data owner that you have been infected, but the government also needs to know it for society reasons. And that is something that we need to enable in our architectures. Otherwise, we will not be able to basically get the benefit from protecting also the rest of the society. So that is also like a thought or like a leading thought that what we would like to have in our architectures. Then we have the field of self-sovereign identities. Of course, that is also something where we can look at. And organizations already use digital identities to verify their users. But self-sovereign identity says that a user is owning its own digital identity. And of course, we have disposable yet official identities. That is why we are here together today, because the user should also have different pseudonyms for the different purposes, to log in maybe at different internet service providers or to use it in each company that he's working. So that is also something important to keep in mind. And also the disposable yet official identities, they would allow a user to use services with much more privacy than before. Until now, we always have to generate a login, like me today, when I try to log in and get my presentation. And suddenly, because the phone number is not recognized or they can't send an SMS to a fixed, to a landline, I can't log in anymore. With a disposable or with a self-sovereign identity, that would not have happened. So these are like the inspirational thoughts of things that we would like to see in our internet today, and we partially already see it, and we add solutions that allow us to do so. But I think that we need to do it in a different way or on a different level. Gartner has mentioned, or actually Gartner has coined the term cybersecurity mesh a few years ago, and what they mean is that we need a more composable and flexible approach to basically add cybersecurity measures anywhere in your landscape with a finger snap. So you would like to have most of the cybersecurity measures that you can do, like adding a virus protection, setting up the firewall. You would like to have that anywhere, and it should just be configurable for your company. And that is especially needed because also from the pandemic, everybody had to work in the home office suddenly. And that, of course, is easily attackable because there's no equipment, and all the laptops were not in place, or were not did not have the software stack to basically be safe from external attacks. And we see that in the statistics. So the losses because of IT security attacks, they are rising. We now have the increased regulation from the European Parliament, the Cyber Resilience Act, the NIS2 directive, and that is not coming out of thin air. So we see that this is going to increase probably also in the next year. And we have the completely different political environment. So companies have to do something, and it's difficult to counter all the cyber attacks that are currently happening. As I said, we started our development in 2016 already, but we are coming from actually from a completely different background. We are coming from the background of enterprise integration. So we are connecting different IT systems. And we saw that there was more IT security coming. And we thought, like, how would it be if we could basically enforce good security best practices directly from the start, so that we don't have to build a security gate somewhere and then think that the integration is secure just because we have integrated a security gateway. And that is what our approach was. And at the beginning, we just played around a bit with the algorithms. And now we are in a state that you can use it. And basically, our product is just a small C library, technically speaking, that you can integrate into your product. Or to put it in other words, we are a protocol definition. We are a protocol definition with a reference implementation in C. And we can run basically anywhere. So we can run on a small Raspberry Pi. We can run on a mainframe. We can compile it for every kind of platform that you would like to have. We have some language bindings so that it's easier for you to use our protocol from other programming languages. And we only use the modern cryptographic algorithms that are there. That means we only go for the elliptic curves, for example, and we only use the XOR encryption, the Cha-Cha algorithms, and so forth. What do we mean with security first? Of course, from the zero trust architectures, we use digital identities. We have 2 layers of encryption. I will explain that later in a moment. We do embrace attribute-based access control. But most importantly, from these here, we can do object-level permissions over the network. That means we have much finer granularity than before with TLS. And we can decentralize the access, because we can delegate the access to other participants in the network. What do we mean with privacy first? We use stacked or pseudonymized. I'm always struggling with the English word of pseudonymized identities. And we have something that is that we call blind broker node. So if you place a broker node with our solution, then it's not able to see the content because we have implemented the end-to-end encryption. And also our discovery protocol is based on privacy. So it's very hard to see actually the data that is coming. And that allows you to actually interact with all of your company, even behind a closed firewall. That is something that you can't do with any other protocol, at least to my knowledge. So you can work from behind your closed firewall, and you can work just as if you would be in your office. You will have, of course, the increased delay, but everything else should just work. And of course, we use the disposable identities. And that is what I would like to explain you now a bit. How does that actually work? And maybe we can have a short break if you have already questions before I now go to more into like a deep dive what we are doing. Or maybe one of the other participants has a question already. I don't know. Yes, Michal has one.
Yeah. Maybe Pier Paolo, would you, is there something that you would like to say at this moment, or?
Otherwise, write the question into the chat.
Yeah,
I think
that's...
Vishal had one question.
Yeah, for me, it's yes. Vishal just writes in the chat.
Okay, yeah.
Yeah.
What would you advise for small startups in terms of security aspects? I would advise it depends on the startup type that you are. If you are just there to sell something to different ones, so you're just looking for the money, then you don't have to care about security aspects. Uh, if you are looking for the long-term commitment and you would like to build up a real company, then you should embrace security directly from the beginning. It doesn't pay out anymore to not do it. The regulation will increase, and I guess it will even increase in the next year. And there are already obligations that you have to fulfill. If you have a very special solution where you don't have any network access, you are concentrating maybe just on an algorithm, a specific one, then you may think other about it. That would be my advice. Does that answer your question? If you develop a website, then you should embrace security from the start. So think how you can authenticate your users. If you would like to enable a user login, think how you can secure your web page. Be careful with ads, because also ads can bring malware to your customers or to your website users. All these are points that you may think about. Zscaler. I have to look up Zscaler a bit later. So I will come back to that question later. I have heard Zscaler before, but I have to take a look whether that is the one that I'm thinking of. Is that okay? Yeah, I think so.
Yeah, what I find fascinating also is, I would say that the way that you described it so far, that Pila would be amazing to start an enterprise architecture, sort of to really to make sure that this protocol is embedded from through the entire stack, through sort of so if you're talking to companies now, at what point do you think you could get in more easily with the solution than in other points? So maybe it's a question for later, or
No, it's a good question. Probably it's easier to talk to startups that they integrate the protocol. But it's a bit also a question of an ecosystem. Of course, if you start to use this as the protocol, then also others have to use it. So you can use it internally already to secure things. But at some point, you would like to talk to other companies, and they also have to use this protocol. And that is then something that makes it difficult. But that is also anyway difficult everywhere if you start to do integrating the integration with other companies, because then suddenly both have their protocols, and then you more unfortunately often you find the weakest protocol that you can agree on, unfortunately. Okay, so I will look for set scalar later. Already had a small peek. But then let's go on. Let's talk about the old TLS scenario. So that is what everybody knows. We have TLS connections. We have lots of them, but unfortunately, it's always Alice in Bob. So it's always just two persons. It's hop by hop TLS encryptions, and we can make this secure, but we then still have privacy risk because our IP addresses, for example, are leaking. We don't have any kind of group communication between, we just have Alice and Bob. And that means if we would like to go into a kind of group communication, somebody has to become the coordinator, and that is somehow missing in the current TLS or TC, in the current stack. We have malware risk because, of course, if Alice is publishing her public key, anybody can send her messages. And we have denial of service attacks because Alice and Bob have to be publicly addressable. Otherwise, you can't send them any messages. And that is basically the old scenario that we are coming from a bit. So in a nutshell, it's a smaller example. And the question is, what do we do differently with the Neuropil protocol? And what we do differently is we use under Alice. So Alice and Bob, they use in addition random identities. That is a bit like the disposable identity. So Alice and Bob both can use additional random identities. They can use more than one. And they let the random identities connect to each other. And that automatically gives us like a group communication path. And there are multiple paths actually to authenticate now Alice and Bob. And that means each of the both is authenticated at least once. And the point is we can use these random identities for more than just this kind of connection. We can use it to basically spin up a network of random identities. And each of these random identities will give us a hash value. That is what our distributed hash table is based on. And that means we are automatically, instead of DNS, we are using these hash values. Like in the named data networks, they use the file name. In our network, we always use hash values to identify the different peers in the network. And due to the random identities, the network becomes somehow unpredictable. So Eve here in the middle, the eavesdropper, he doesn't know actually which connection is really the important one. And then on top of this network of random identities, we can layer different kind of communication paths. Let me see the next slide. Yeah. We can do a discovery on top of these random digital identities. And because we can talk about subjects. So like in the named data network, if you have a data object, we can give that data object a name. And from this name, we can create a hash value. And that hash value basically maps to our hash table. So we can use this like rendezvous point. So for every data object, we can generate a rendezvous point on top of the random digital identities. The same applies for a digital identity. There's also like a rendezvous point in our network for this digital identity, or we can use it for basically everything. So you have an address for it, but we know that it is fuzzy. So we know that the random digital identities will never have the same hash value like any of the ones that we generate for our subjects or for the names that we use. And that is something that we use to our advantage for cybersecurity. Because when two, like Alice and Bob, they would like to talk to each other, the first thing that they do is they exchange a disposable identity. We call it an intent token, but basically it is the same. So from our digital identity, we derive a specific token that is just there for this single data channel. And the data channel can be made, for example, for an IP address. It can be made for an application, but it can also be made for a collection of objects, or it can be even made for a single data object. And that means there is no granularity limit how you use our library or our protocol and what you would like to protect. And by doing this, by adding this kind of intent token, we are basically okay, I will come to that question later. It's unclear how Bob initiate connections with Alice. I will come to that. By adding this intent token, we can distinguish now suddenly between 4 different kinds of transport types: virtual, public, protected, and private. Because we, with a virtual data channel, we only exchange a token, but no data at all. So we only use it to exchange our identity, our disposable identities. With the public one, anybody may connect. So we have a group communication channel. And with protected, we limit it to a specific audience that is also a field of the token. And then for private data channels, we can basically create different kind of fingerprints, or we can use the fingerprint of Alice together with a name to create a private data channel. The question, how Bob initiate connections with Alice, that is basically like before. So each of these connections in this picture is a TLS connection. It's just that we make sure that we use a random digital identity, and we can already deliver a fingerprint of Alice, for example, in this random digital identity. But we do not expose any additional information about Alice or Bob on the first handshake. So we first make sure that we have a lot of static random connections. And on top of these random connections, we then can establish additional data connections. Did that answer your question? Let's wait a minute. Right, how Bob get to know such identities? Either Bob is publishing his own, so you need a kind of bootstrap node, but you can cross-connect these bootstrap nodes. So Alice could run his own bootstrap node, Bob could run his bootstrap nodes, and they can connect. But it's not a single instance that you need. So everybody can just set up his own bootstrap node and can see what other kind of bootstrap nodes are available. And because each of these are running random digital identities, we do not, the main difference is we do not expose any kind of data by connecting these random identities. We are just allowing them to be part of the distributed hash table, and no additional data can be transferred. If you would like to then exchange more data, then you first have to exchange the intent token. So that is like a second layer of access that we introduce and that we use. How do we prevent node impersonation? By using the intent token. And as I mentioned, each node and even each random digital identity is authenticated at least once. By exchanging all the different fingerprints, each fingerprint is unique to even to a random digital identity. You will get to know if there are double random identities. Maybe we can also discuss directly if you would like to. Okay. That was yeah. So question hopefully answered. Otherwise, we can discuss later on as well. Okay, so we stopped here. So that is how we use the disposable yet official identity. So it's our second layer of defense. And we can also use this intent token because now we can exchange more than one person. So it's not only Bob and Alice who would like to talk to each other, but we can also add Marvin, Eliza, or anybody else. So we always exchange these kind of intent token. And by using it, this is always a temporary one. We can limit it by time. We can limit it from the scope. And we can ensure that the authentication of all these digital identities is in place. And each of these intent token is for a specific data channel that we then use. And therefore, we have then a selective access control over content. So it's not, as I mentioned before, by joining the distributed hash table, you do not expose any data, or somebody cannot send to you any kind of data. He can just participate in the hash table and nothing more. If he would like to communicate with you, you have to do something in addition, and he has to do something in addition. And that is done by the disposable identities. That means we have we have less malware risk because we have this additional intent token where you need to do the authorization. And that means also you set up a data channel for a specific kind of data that you would like to receive. And that also means you can validate the data very strictly. That is different in some of the data that we receive. If we take, for example, email, then we have introduced the attachments. So you get all this information at once, but then it's difficult to basically validate all the data that is coming. In Neuropil, you would have one data channel for the actual text of the email, or you would have then one additional data channel if somebody would like to send you a specific file or whatever, or an invitation. And that means you can basically, for each of the different data channels, you can do the validation. And in addition, everybody who would like to send you something, he has to become visible. So he has to become visible with his digital identity. It's not somebody who can just send you some spam mail or whatever. Everybody has to have a digital identity. And it's not possible to just send to you something because the addressing in our solution is always indirect. You always have to go via the distributed hash table and the additional discovery. In a similar way, this denial of service attacks are not possible anymore. Also because of this disposable identity that we use. So you have to authorize somebody if he should be able to send you something. And if you just receive something from somebody that you did not authorize, we will just throw away the content. So that is possible. Also, because of the random identities, you cannot basically directly attack because the attacker doesn't know which of the random identities is the most important one for you that you use. And that basically means there is no spam anymore. So everybody who would like to send you data has to ask for your permissions. And he will he will only know if you have given the permission, if you respond, or if he then gets a reaction. Otherwise, it's quite useless to send the data because it doesn't know where it will go to. So if we look at the complete construct of Neuropil, then sometimes we say it's giving you cyber resilience superpowers. So we have these virtual public protected data channels. Basically, every data channel that you set up with Neuropil, or the way how you use it, is a VPN connection, even for a single data object. That doesn't mean that you have to do everything for a single data object, but that you could do it for a single data object. And that also means for your company, if you're looking for a VPN solution, here is one. And it's cost-free, it's open source. You just have to use it for your own purposes. We can do verifiable environments on startup because we can actually expect that certain data channels or certain digital identities are available in our environment, and then we can check that we can reach them. Integrated, we have data provenance and data ownership. So data provenance, because for each data channel, we do know who is the sender of the data and where it was coming from. And we can go for truly passwordless setups because we have all these digital identities. That is also possible. The main point here is we can run hybrid web of trust and public key infrastructure settings. So web of trust means that is like the distributed hash table setup. But in corporate settings, you often want to have a PKI, public key infrastructure, to basically shape a bit the authentication and to shape your how the organization is set up. And with Neuropil, we can support both of these models, and you can set them up both at the same time. So you can have like a digital identity that is signed by a PKI and that has received additional signatures from a web of trust, for example. Be aware that there is a limited set of signatures that you can receive, so it's not endless. It's just like, I think, I'm not sure, I think about 10K, that is the maximum amount of attributes that we can add, and a part of that would then be available for additional signatures. There are some more cyber resilience superpowers. That is one of the slides where I lost my picture, unfortunately. We have received one grant from the Next Generation Internet that was in the field of search. And that means our solution contains a distributed search engine that you can use. So from text content, we can generate a search entry, a privacy-preserving search entry. In that meaning, the privacy-preserving, of course, is you don't want to expose all the text that you have written, but just a fraction of it that is searchable. But of course, it is attached to your digital identity, so you want to be found. So that is a bit contradiction. And we can exchange the search token, and we can do a distributed search for you. That even works if you would use encrypted text, because the search algorithms basically don't care if it's text or if it's encrypted text. It's just pure mathematically how text is found. So that is possible. We have one more cyber resilience superpower that is a rather new development. We call it democratic access control. And that is basically a bit a reflection on how we establish trust. So we have like the 4 roles: legislative, judicial, informative, and executive roles. And each of them plays a role also for cybersecurity. So it's about defining rules, enforcing rules, monitoring rules, and then basically requesting a change or to see whether the monitoring is the right one that we would like to have. And our current idea is to establish 4 timestamping authorities for each of the different roles, and that we can then exchange the information quickly to basically increase the cybersecurity response a bit. So that's a new development that we are currently working on, and we will see. We also have done a proposal for distributed time. So if in the internet we do have a time protocol, we are of course aware of it. But in the Neuropil protocol, we do not have the direct connectivity as in the current internet with all the TCP connections. So we have started a protocol which we call steps, which is more like a decentralized time. So the different nodes that you see here, all the different random nodes, they influence each other with their time measurements. And we do already time measurements between all these random digital nodes, and we can use them to basically come up with a common time without the need to have the direct access to a time server. We just need to know whether somebody that there will be time servers somewhere in the network. That is important to know. But that we can do with virtual data channels, and then we can also basically get some time impression via the virtual data channels. We try to reduce the external dependencies. So as I said, we don't depend on DNS, and with the implementation of the STEPS protocol into the cybersecurity mesh, we are also becoming independent from the time servers. And that means it's a fully integrated protocol that we are using. So what's next? What's on our agenda? We have received 1 grant from the Fluidos project, that is an edge to cloud continuum project that has also received funding from the European Union. And with that, we have started a Kubernetes integration. So basically, we give the Kubernetes now a different kind of overlay network, because before it was based on IP4, and that was the kube proxy component in the Kubernetes. But we can give it a zero trust based one. So an overlay network that is based on digital identities. The first component is already in place. We called it a privacy relay. And we are currently working on the integration of authorization logic in the Kubernetes cluster with custom resource definitions. And we are working on the identity part that we can do the automatic signing additional signatures like a PKI for the Kubernetes clusters. Some other developments that we also would like to do is partial data encryption. We have done some proof of concepts here in-house that are looking good, and we would like to switch to Blake 3 as our hashing algorithms. Currently, it's Blake 2B. That's a minor thing. We just have to make somewhere in the future the decision to switch, and then we can switch. Things that are more in the future are the integration of zero-knowledge proof algorithms and the introduction of quantum-safe algorithms. For quantum-safe algorithms, currently there is 1 master thesis running here in our company. So we can have some results in the mid of the year, and then we can see what we will do. And also we would like to add some back pressure and RNLC, that is random linear, it's wrong, it's spelled wrongly, random linear network coding, it's RLNC, sorry. We would like to adopt some of these to basically stream the network packets a bit better than before. So that's on our roadmap. We have received funding. I already mentioned it. We are in NGI, Next Generation Internet project, and we have also received funding from the Fluidos project, and that's really both Next Generation Internet and Fluidos. That's great. They are also great projects in themselves. We would like to set up an open collective in the future But you can also get partner and support packages if you would like to use our software. Of course, it's open source, so you can try it out. You can see how it works, and then let us know if you would like to use them. If you are a company or if you are from a different country, then please let us know. So we are concentrated, for example, on Germany, but if you would like to become a partner in a different country in Europe, then we can align as a partner and you can do the support packages basically then for your country on your own. That is possible. Then I'm at the end of my talk. So thank you for your attention. I've gathered here our web pages and our repositories. That's the official one, the development one, and the Kubernetes repository. If you can give us a star or do a fork, that would be great. And apart from that, now I'm open for your questions.
Yes, I'm muted. So thank you very much.
And I don't hear you. Now I hear you.
You hear me? Yes, I was muted.
Yes.
No,
Okay. Sorry.
it's a
I thought
fascinating.
sometimes my
Yeah, no, it's a fascinating presentation, and there are some other fascinating things in the sense that um, so we initiated this through the Disposable Identities Telegram group, um, and but and actually at the moment I'm working for Mattel Innovate, and Mattel Innovate is a partner in FreeDOS project, and is also a strong partner and has been a strong partner for 8 years from the beginning of the next generation internet. So at the moment, I'm working in a project called NGI Commons, which directly related to the things that you talked about in a broader
yeah.
way. And so I will happily show this to to the NGI community and the Fluidos. Uh, and it's such so interesting that it's in a way such a small world in that we meet through the Disposable Identity Telegram group. And so that's one thing I think that's really fascinating is that there is also this European ecosystem and this European funding system, which there isn't anywhere else in the world. That is actually now this NGI ecosystem has without doing marketing for it, but simply stating that it has over 1,200 open source projects, and that companies like Mattel and also Michiel Leenaars from NLnet is doing exceptional work in all of this. And so that's indeed, I think, when we hear the stories that sort of the States and GAFAM has $7 trillion, and they sure have. It's what we aim to do, in my opinion, is not replicating this type of model, but actually building these mesh network, building these réseaux of communities and SMEs, in which we're so good at in Europe, where we have 99% of our value sort of coming from SME. So, and then in terms of the content, and because I think the beauty of the the project is that there's a heavy load of theory working in it and behind it, but it's also very practical. So that's, I think, a combination that you don't normally find. And to me, but I'm not a technical person, so it looks like kind of the blueprint for a new type of internet, for a new form of TCP/IP protocol that Vint Cerf and Bob Kahn made, one of the most anarchistic protocols ever made, just pass on the packet. And of course, it was beautiful and fantastic, but there was indeed no security whatsoever. And we cannot have a world running on it. So we need a different architecture. And that reminded me also of the architecture of the web, where we had Tim Berners-Lee, who basically put out HTML. And in HTML, you can link to things that are not there. And to someone like Ted Nelson, who had this project Xanadu running, that was really unheard of. It sort of you don't do that. You cannot set up a kind of, so you need this kind of reciprocity. So you need to know, if you link to something, you need to know that is there. That reminded me a bit of your hash internet type of, the broker type of system that would install the trust between the nodes that are trying to communicate. So as far as I can understand it, I know Pier Paolo is very technical. Gino, Michel, maybe sort of very more, but I could understand it. Yeah, this really is kind of yeah, this is something that, if, let's say, if, for example, Europe or a country or a region would be able to restart its communication and information flow system, it could restart like that. And who knows, because the stories of sovereignty and for the past months have become very, very, like everything I read on LinkedIn these days is about sovereignty and autonomy. And also people from the commission are putting out LinkedIn pages on how important open source is, so yeah, I think it's um, yeah, thank you very much for the presentation. It's fantastic work, and this it's a lot to talk about. But yeah, so
Yeah, sometimes it's difficult to explain. I hope it was understandable. I'm sometimes unsure if it's really the beginning of a new internet. It's our approach, I would say. We have to see. But if you think it's worthwhile, give it a try. That is my, and then let us know.
yeah,
Give us the feedback. So that is how things improve.
yeah,
I'm aware that there was one question with Zscaler. Um, and I just had a look at the web page as well. So I think Zscaler and many other companies that I know from America, they are basically still working on IP based. So you could use it for something similar like Zscaler, the zero trust networking part. If you use it for your IP addresses or your DNS names, that should work. But the difference is really that we are completely open to the names that you give it. And that the way how you can derive new names is completely different from Zscaler. And you have to be aware of it, of this kind of difference. Otherwise, it won't be doing what you would like to do. Yes, I can share the slides. And LinkedIn. Yes, that I can also do. One moment.
yeah. So I think I will, if there's no more questions, or I will end the recording, and I'll write a short message about it, and then link it. Yes, LinkedIn. Link it and send it, and then put it on the Disposable Identities group.
Mhm.
So let's see quickly. For those of you not yet on the group.
Also put the link to the group in the chat.
Yeah. I just put the link to the group in the chat. So if you're not yet in the group, just go to the link in Telegram and join the Telegram group. So Stefan, thanks a lot. It's really helpful, and it's also fantastic that you're also in the NGI, the Fluidos ecosystem that we didn't know about. So that's really great. So wishing you all a very good evening, and thanks a lot. Thanks a lot for the presentation.
Yeah, thanks a lot for the opportunity, and maybe we meet with Fluidos. I just received also the email that there will be some additional recordings, so we can maybe present Neuropil in action, because we have implemented this discovery for Fluidos. So that is something that maybe we can also report.
Yes, definitely. I'm not personally involved in Fluidos, but I know people that who are.
Yeah.
So I will definitely also mail them when the presentation is up. Oh, Vishal, the link to the Telegram group is in the chat. Oh no, I put it in the AI companion. You're right. Now it's in the chat. You're very welcome. Yes. Yeah, I put it in the AI companion. I don't know where that is going to reside, but let's see. Yes, thank you very much again, Stefan, and thanks, Gino, Pierpaolo, Vishal for attending, and have a good evening.
Yes, you too. Bye.
Bye.